Hello everybody, how you doing? Now this the video is regarding the menovideo package. This package now this the official page for it, menovideo. Let's talking about the whole idea about it. It's a library for video action recognition and video understanding. You can build with a simple line of code a video action recognition model using PyTorch using this package. So this package is actually built based on PyTorch to make your life easier when you're working with videos. So the core model that is being used inside and developed is the official implementation for a paper. It's my paper called Data Efficient Video Transformer, and this is a new approach that I have came with. The idea from this method is to build an efficient video transformer network that's capable of working if you work with the videos, if you have seen any models like the Timesformer and other models that for video action recognition and video understanding. These models based on transformer need a large amount of data and good hardware resources. While not all the researchers or other have access to a similar kind of hardware resources and data, because this is a special case for big companies like Facebook and so on. So Facebook came with the Timesformer. It's a good model, but you need a large amount of data to coverage. And my video transformer, data efficient video transformer, for short DEVTR, is work based on and can give you a good and a great result using a limited data set, a small number of data set. The model has been benchmarked on a dataset called Real Life Violence Detection Situation Dataset, and combining the model with others in the field. So if you see in here that we have combining the model, so this method, data efficient proposed method, has achieved 96.25%, which is higher than any work done before. Now this transformer is by Facebook. It's found it's need a large amount of data and also good hardware resource to coverage, while our model has needed small data. And also this method has using the traditional CNN plus LSTM, and others has using convolutional 3D. And from benchmarking and testing this method, our proposed method is seem to be the best. And here that you can see that we are the state of the art in this data set. And to summarize that, what menovideo give you, actually menovideo have things to give. The first thing that you can easily use our DeVTr. This is the official. This library contain the official implementation for our data efficient video transformer, and you can customize on it. Second thing that we have ease of use video dataset loader. So reader, this reader will help you reading videos, doing some kind of a pre-processing on it. So will make your life easier when you're working with a video dataset. And the second thing is that we give you time distributed warper, which is an abstract layer similar to keras. There is no implementation yet for this time distributed on PyTorch. We implemented inside our library. So this is the main three things that you can get from our library. Um, and so to start to show you how you can work with it and how you can install it, we will have two demonstration. The first thing, the usage, and the second thing is a case study or a real world example. So using it when it's retrained. Okay, so the first thing it is that it's you need to install Tim, so it will make it easy to you to use the pre-trained models. And this is just I am mounting my Google Drive so I can use the trained weight. Simple. You can just import PyTorch and open CV and thing like this. But this is just a simple library importing. Now the first thing that you want to do is you have to do pip install menovideo. This is the how you can install the library. So just you hitting this. Now the system will download it and so you can use it. Now you can import two things: the menovideo and video pre, which contain a video process, a video reader. So the data efficient transformer implementation is inside this menovideo. I import it as and call it menoformer, and the reader and dataset reader and video processing is under vid reader. So this is the main import that you can do. Now you can simply call menoformer.devtr if you want to use the default structure without any pre-trained weight. So you don't want to use our trained weight, which is trained on a real world live situation data set. You don't want to use this weight. It's okay. So you just call this, and actually this contains some default value, W, which is the path to the weight, our pre-trained weight for so if we provide more another pre-trained model, we'll add it to the list. So currently we only trained the model on the real life situation dataset valence. The base is the base. So the idea is that we're using a convolutional neural network as input embedding, and this is the base. Then we're using positional encoding to capture the locations of the frames, relationships of the time. And then we have a transformer encoder layer, and then we will have a classifier network. So here that we call in the base as a default. So the system will use VIG19, which we has used in our work while we are benchmarking, but you can provide it in other network. Then the classifier, if default, it will give you our architect of classifier. You can change it later. Also, this is the mid layer. I have written it here. So the mid layer is the fully connected layer that is directly after the transformer. So we're talking that there is input embedding, and there is a positional encoding, and there is a transformer encoder. Then the output of transformer encoder is sent to mid layer or the classifier. So here, how many neurons it will have, and here that's a drop out for this mid layer, and then the number of classes that if you want to classify it, how many classes in your work. In our work there was a binary classification, but of course you can change this number as you have the task in your head. And this is the dimensionality. So when you're doing input embedding, you want the data to have some kind of embedding size, so you can define it here. And this is the dropout rate inside the transformer decoder, and the time step is the number of frames. So you give it a video, so you have to set the number of this. But using the default architecture, everything is set, as you can see, as this value is being set into you. So this is how we just importing the default without any pre-trained weight. So this is just the model will work based on the VIG19 as mentioned to you, and then everything will complete after this. And this is the architecture of the model, as you can see. So there is the embedding, the base network, and then there is our positional encoding, and there is the Meno transformer, the transformer encoder layer, and then is the fully connected network, and then the classification, how many the number of a class, which was a binary classification. Now if you want to use the pre-trained weight based on what we have said to you, that we have training the model on real life situation valence dataset, you can download it from this URL. So just you clicking on the URL and download it. Then after you download it, you just provide the path to the weight and set the base to default. This is what you have to set. Now we will use our pure and official implementation of video transformer network data efficient video, which is on this paper. So using this line of code, sorry for that. Using this line of code will give you our official implementation with its weight, which is has gained this accuracy on this data set. Okay, so you will have ready to go model so you can work with a violence video without need to training and working with any overhead. So let's see that it can run. As you can see, it will run successfully and then everything is good. You just loading the weights, give it the path of the weight, and said that you want the default Bayes network, so it will understand that you want our DeVTr with its pre-trained weight. Now, this regarding the model that you are using, the model, but what if you want to customize, how you can customize? Okay, so the first thing, I'm just showing you that how Tim is listing its model. We are using TIMM as building the Bayes network. So actually what we are doing, you can provide for us an sequential model. Here that we accepting this, we building a Bayes network which is ResNet 26 pre-trained, and setting the number of classes as the dimensionality embedding. How many dimensionality embedding? We want it to be 128. So this is will be the when we feed in the data to embedding layer, which is this network, it's the system will give us this embedding dimensionality. So you have to set this in the number of classes. Then how you can do it, it just you said that you want the Bayes to be this Bayes model you have already created. How many classes you can set as you want, and you also have to give it the dimensionality embedding, the number of the dimensionality embedding that you have, so it can understand this, and also it can complete its work. So if you see in here that we fully customize, we already have been completing this, and as you can see, this has been done. Okay, so what if you want to do some customization on the classifier network? So the classifier network, you can also give any sequential network. So we just setting some parameter here. We're building the classifier network. Now we just give it the classifier network, which has been defined as an sequential, given the number of classes as we want, the dimensionality. You just have to be careful that this is the classifier network. Its input has to be the time steps, which is the number of frames, multiplied by the dimensionality, the input embedding dimensionality. And then everything that's set to you, so you can just import in this. So now if you want to customize the classifier and input embedding convolutional neural network, so this is a full customization. You will just use the default, you will just use the schema of the work. So you will have a full customization over the Bayes and the classifier, and so all you have is to give it the Bayes network, the classifier network, and you have to give it to, so it can do its calculation. You have to give it the number of classes, the dimensionality embedding, and also the time distribution. Now this is for the customization over the network, and this will set the network to you as you have been set in your code. Now you just to make sure that we have in the right version of this, just now if you want to use some helper function, which is that we have time warp. We have mentioned that we have implemented time warp, our own custom time warp, and this is the first implementation in any package that's been used in PyTorch. You can use it if you don't like use our schema of using transformer and you want to use the classical CNN+LSTM for completing this task. It's up to you. So how you can benefit from our work? Yes, you can. The first thing is that when you have a convolutional 2D, when you want to give it a video, it cannot work with it because the convolutional network need data with the size, with the shape of that you have a height, width, and color channel. while the video is the number of frames, height, width, and color channel. So what's this is doing is that it's apply the same convolutional neural network to each frame, and this is the main on the idea of the time distribution. So we define our normal, very normal Vig 19. We're doing some freezing for some layers and unfreeze some last layers, and also that what we will do is the first thing that we wrapping the base model, which is this convolutional, inside the warp, and then we define our colors, LSTM. Also, we want to take only the last output from this from the last cell. So we also give you a helper function called extract last cell. So when you're doing this, it will give you the output from the last cell, so you can easily feed it into any linear layer. So this is using our helper functions, time warp and extract last cell, to help you building CNN+LSTM architect. And this work is also if you want just use this thing. Now, how you can use it in a full project? Let's say you have a data set, you want to train, you want to do something. So first thing is I'm just let me just recap it on this. I have to uploading this. So we have a data set from Kaggle, and this data set is the same data set we have trained the model on. So I just want you to see how the work is done. And now we downloading the data. We will go through this code as one by one. So we just getting the data set that has the model has been trained on, but you can use it on any other data set. So all the idea is that we are going to work on the code how to get a data set and make the system work on it. Okay, so while it's running, I'm going to show you that where is the benefit of menovideo. Now, since you have a data set, we want from you a CSV file or a data frame that's containing the path and the class for each video. That's all. So once you have the CSV file or data frame, so what's we have the vid reader, which will build you a dataset class that it will reading each video and taking the exact amount of frame from it. You said that you want 14 or 13 frame from it, and we'll reshape it with the height and width and color channel, and we'll get it back to you. So you will have a full data set. You don't have to do any work here. It's just that you give it the data frame that's containing the path and the label for each video, and you will have to set the dimensionality of your video. How you want your system work with it. So the library will work. Will go to the paths and read the video and do its work, and it will do some normalization and converting to PyTorch tensors and things like this. And also we will going and incrementally adding some kind of video augmentation. We have this on our work right now. So once you're doing this, you will have this data set, and you can use it in your data loader. And then we just has using our normal model and use it in test, and it will test and work for here. While this running, it will take a time. Let's see a real world example how we using the pre-trained model, which is pre-trained on a violence event videos. How we will use it, let's show you that if we can use it reading some kind of videos and loop around it, and seeing how it's showing us it's detecting the violence from it. So let's see this thing. Okay. Let me run the code. This is just simple code to show you I'm going to use my pre-trained menovideo on a data. So what I'm expecting here is that I'm going to have that the model will the code will cut any video that containing violence and put it here, and also print to me that it's seeing video action inside this. So just let's run it. So now this the video is playing. I am just playing the video in a normal, very normal speed. Not so now what are doing that we each 14 frame if we detecting a violence, the system will show some text here because it's a speed. It will a blip and will cut the video containing the violence event and put it inside this destination folder, and this will be shown. This is out scope of the library itself. It's just showing you how we benefit from the pre-trained model inside this library and use it as go without training, without anything. Just we take it, we import it, we just define, we just use it directly in our code and it's work directly like a charm and everything is fine. Yes, you will see it now. Let's just look at it, the video. So now this is just the video is running and while when the event since there is no event here, the system not screaming and not sending any signal. Yes, we have to wait for the video and see if there is any violent event will happen. Simply we are running this on our system, and this is very low hardware resources here, and you see that the video is working good, and this is the normal speed for the video if you run a CV2.am show. So it's not that slowing it because it's will run on this speed. For sure I can increase the speed for you, but we set the speed for a normal printing. Till now there is no violence event. So this tiny stub you see is that it's checking with model and see its answer if there is a violence. So it will get a chunk of video, check if it's contain a violence. If not, it will continue. If it's contain, it will continue and show you alarm and outputting a video. So now, as you can see here, the event has been started and you see something. Now, as you can see in here, yes, this is the output, and he said violence detected. So it was showing something here. See that it starts and then as the what is give you on the it's give you your action recognition base model that we did is used for this model, which is called we give you a video understanding of PyTorch is very library that